I guess you're going to need a calculator. Do you guys have a calculator with you guys by chance? Perchance? Wait, not perchance. By chance. Here's my little calculator. All right. So right off the bat, change of base properties. We kind of already touched on it. Ln is just so these are the same essentially. These first two here, same. Sometimes it's written this way, the second one, but it's the same thing, and they're called change of base properties, guys. So if I wanted to portray like log base 3 of m, that's the same thing as saying log of m over log of 3. Notice I didn't put a base on it, so that means that both of these on the right hand side is base 10. But remember, this is the same thing. I could give it whatever base on the right hand side. I can go log base 7 of m over log base 7 of 3, as long as I keep these the same, see? So yeah. So that's why it has this log base a of x equals log base b of x with log base b of a. And you can always do that. It's called the change of base property. And let's see, what else? Log base a of x is equal to ln of x over ln of a. And they're all the same. So you could say also ln of m over ln of 3. See? What else? Oh, yeah. ln is natural log. And natural log is just log with a base of e. That's all it is. Clear. Cool or not cool? All right. Let's go ahead and get right into it, guys. Sometimes we laugh, sometimes we cry, but this time we're going to do math. I practiced for that, but it didn't come out as good as I thought it was going to come out. That's from Drake. Last time it was Kendrick Lamar, now we're... Okay, I'll stop. I want to solve for the power 3x, guys. You want to solve for x. So I'm going to first write 7 to the power 3x equals 983. So we want to bring the x down. So how do you do that? You use the power rule of one of your logs. You could use log with any base, but I have a tendency of using natural log. So I'm going to change my colors. If you have colored pencils, I'm going to write ln. Whatever you do to one side, you do to the other. So it's really ln of that and ln of all this right here. So what rule am I using? I'm using the power rule. I'll put it here in the side notes. Ln of a to the power b is equal to b ln of a. So that's the rule that I'm using. So I'll bring that 3x down. So you're going to have 3x ln of 7 equals ln of 983. You want to solve for x, so this is all a product. This is 3 times x times ln of 7. So to get the x by itself, you just divide by 3 ln 7. So x equals ln 983 divided by 3 ln 7. That's not the only way you can write it. You could also write it like ln 983 divided by ln 7 to the third power. But I actually like this one here. It says using logarithms to solve algebraically. How else could we write it? I could write it like this. This one in blue. I'm going to write 1/3 log base 7 of 983. See? What's up? Oh, I just like with the very first fraction. Yeah, see how this is 3 times x times ln 7? So I want to get the x by itself. So I just divide it by 3 ln 7. Whatever you do to one, you do the other. You know what I mean? Or are you just telling me that? Just, okay. I like how you do things in threes. Yeah. No. Okay, I'll stop. All right. Yeah, so there it is. By the way, I'll show you with the calculator, guys. We got time. Unlike the morning class, they didn't have time. So if I take my little calculator here, I can go, let's do the little fraction thing. Ln of 983 divided by, with a 3 ln of 7? Enter. Check it out. And if I do it again, and if I go ln of 983 divided by ln of 7 of the, go to. I meant to type in, let me scroll, let me delete this. I meant to type in 3 ln 7, but I didn't get a chance to. Ln 7 to the third, 7 to the caret 3. Oh. Enter. See? Same thing. You could also did, what did we do? 1/3. So I said 1/3 log base. The log base is on math, and you go to AC. And then log base 7 of 983. Look at all the different ways you can get the same answer. See, they're all the same. Boom, boom, boom. Isn't that cool? So, yeah, cool. All right, so let's see what we got next. Yeah. Oh. Okay. All right, guys. Example 2. Solve the equation. So what we want to solve for x. So we have a plus in the middle. We have equals 3. So the way to do this is you want 1 log, not 2. So there's a plus in the middle. I'm going to be using this property. Log A plus log B equals log of AB. This is called the product property for logs. Is that cool? All right, here we go, guys. So I'm going to go log base 2, big parenthesis, and I'm going to go little parenthesis, x minus 1, close, open, x minus 3, close, close, equals 3. Now we're going to turn this, or I'll slow down. We're trying to solve for x. So we're not going to cry. We're going to kind of laugh. Okay, I'll stop. That was really bad, right? Okay. I'm going to go ahead and turn this into an exponential, guys. So you're going to go 2 to the power of 3 equals that expression. That's just your how to turn it into exponential. So 2 to the power of 3 equals x minus 1, x minus 3. I hope that we're fast enough, that we can go fast enough. I hope that on the right-hand side, you can just do it like this. You can just go, oh, yeah, that's just x squared minus 4x plus 3. I hope we can do that just by looking at it. But if you don't know what I did, I just foiled, guys. X times x squared, x times negative 3, negative 3x, negative 1 times x, negative 1 times negative 3, positive 3. You see what we did? 2 to the third power, 2 times 2 is 4, 4 times 2 is 8. And then hopefully it looks like this, and you remember like, whoa, we did a whole bunch of these in algebra. So in algebra, this is just a quadratic. If I want to solve, I need to get this to equal 0. So minus 8 minus 8. So 0 equals x squared minus 4x. The difference between 8 and 3 is 5. The 8 is the bigger number, so you keep the negative. I said 5, but I wrote 8. There we go. And then you ask yourself this. So when you're solving this one, two numbers that multiply to give you negative 5, but add up to negative 4. 5 and 1. The 5 has to be negative because I want to add up to negative 4, and the 1 has to be a positive. See? And then you just solve. The only way this will be 0 is if x equals 5. The only way this will be 1, the only way the output will be 0 is if x is negative 1. So at the moment, you have these two answers. You have x equals 5, and I said negative 1, and I just wrote 1. Negative 1. And negative 1. The domain of all logarithms, here's how the function looks like. All of them look more or less the same. It just depends on the base that you have, but they all look more or less the same. So the domain is x larger than 0. So if I look here, I have an argument, x minus 1. So for this one, it's x greater than 1. For this one, I guess I'll show the steps. X minus 3 is greater than 0, x greater than 3. You want the one that's most restrictive. So you want this one. So that means you cannot be negative 1. So this is not an answer. You have a calculator, guys, so you can verify this. Chop, how would we verify? Like this. You take a calculator. I'm going to go of the x. Those are the answer outputs, right? I'm going to go math A or math log base of 2. And let's use the 5. 5 minus, what was the first one? I forgot the first one. What was the first one, guys? X minus 1. So log 5 minus 1 plus log base 2. And then what was the next one? 5 minus what? Come on, guys, help me out. 5 minus 3. 5 minus 3. Enter. Bam. Look, it worked. If you were to try the negative 1, Well, now that I have it, there should be faster. You know what? I'm just going to cut and paste. If I were to try the -1, second insert -1, and then delete the 5. And second insert -1, delete the 5, enter. Look, you get a non-real. So you would have gotten it right anyways. But I would like for you guys to know that, like, definitively. You know what I mean, guys? Yeah, cool. All right, let's go to the next one. Why does it look like that? Let me close this completely. I don't like why it looks like that. Like it when I maximize it, you can still see the bottom menu. That's what I'm talking about. Like, see, I don't like that. Okay, max. I shouldn't be able to. That should be able to take the whole screen, but it doesn't take the whole screen. Do you guys know what I'm talking about or no? Okay, sorry, that's not your issue. That's probably a programming issue or something. All right, next question. Example 3. Solve the equation and check your solutions. All right. Anytime you have something like this, I'll just tell you guys. When you were in Algebra 2, you solved quadratic equations ax squared plus bx plus c. You had to set them equal to 0. And you got all your x's by doing -b plus minus square root of b squared minus 4ac all over 2a. I'm not saying that you have to factor out for this one. You don't. But I just wanted you guys to, I want to talk about a topic. Guys, it doesn't have to be an x. It just has to look like a quadratic, like quadratic form, not look like a quadratic, but be of quadratic form. Chop, what do you mean? I can have this, a triangle squared plus b triangle plus c equals 0. And then I can just say, well, my triangle is equal to -b plus minus square root of b squared minus 4ac all over 2a. See? Oh, you guys don't like triangles? You guys are triangle haters? Okay, I'll use happy faces. Happy face squared plus b times happy face plus c equals 0. So happy face is equal to -b plus minus square root of b squared minus 4ac all over 2a. If you can factor it, but it has to be a quadratic form. Does that make sense, guys? Okay, Chav, why are you telling us this? Because this looks like a quadratic form. Look, let's rewrite it. E to the x, close it, squared minus 3 times e to the x plus 2 equals 0. You don't necessarily need to use the quadratic formula. This is similar to x squared minus 3x plus 2 equals 0. And when you guys were in Algebra 2, you factored this one out like no one's business. See, look, I don't like that this is doing this. Sorry, the little things that grab my attention. So look, you can factor that out. X minus 2, x minus 1 equals 0. How do we feel? Nothing crazy, right? Okay, so here we go. Now from there, you can see that x equals 1 and x equals 2. So it's the same thing with this, guys. I can factor it out. I can go e to the x minus 2, e to the x minus 1 equals 0. And just in case, because maybe someone didn't ask, Chav, this is to the power 2x, and this now you have e to the power. Well, yeah, this is the same, guys, because a power raised to a power, you multiply them. So I can do that with that, see? Because no one asked me, but I'm assuming, maybe one of you has that question. All right, here it is. E to the x equals 1 and e to the x equals 2. We haven't solved for x yet. Use natural log. Did I put that side note over here? All right, real quick, another side note. ln of e equals 1 because ln of x and e to the x are inverses of each other. So put that up there, ln of e equals 1. So anytime you have e, definitely use ln to bring the x down. So I'm going to start with this one first. That one you don't have to do it because let's see if we know. I'm going to write, I'm going to write e to the x equals 2, and then I'm going to get a different color, and I'm going to write ln and then ln to indicate that I'm inserting that. And then I'm going to write x ln of e equals ln of 2. And remember that we said that ln of e is just 1. So x is ln of 2. That's my answer. That's one of my answers. All right, this one. We don't have to do all that. Anything raised to what number equals 1? Do you guys remember from your Algebra 2 days? 0. So that one you can just say x equals 0. Would you have still gotten 0 if you would have done ln? Yes, you still would have gotten it. Look, ln, and then you would have gotten x ln of e equals ln of 1. Guys, ln of 1 is 0. If you take your calculator and you go ln of 1, ln of 1 is 0. See? Cool, right? Are you not entertained? Okay, I'll stop. There's my 2 answers. And then test them. I think they both work. E to the 0, so 1 minus 3 is negative 2 plus 2 is 0. Yeah, that one works. And I believe that ln of 2 also works as well. Let's find out. If you want it to be clean, Chav, how do you make it clean? So instead of typing ln of 2 everywhere, check this out. I'd go ln of 2, and I'm going to store that to a letter. Store alpha A, and now I can just type A, and A is ln of 2. So E, so I'm going to E to the 2x, so E to the 2A. I already forgot, what was it, minus 3? Minus 3 E to the A. And then with it plus 2? Plus 2, check it out. Bam. You get 0 also. And remember, A is ln of 2. So both work. Cool, right? Okay. Vamos con Dios. Let's go to the next. I know it says example 7. Like, Chav, we haven't done that many examples. I had a lot of examples, and I deleted a whole bunch. So, nah. Yeah. Did you guys not see that coming? You should. Today was so funny. You know what? I better not talk about that one. It was, yeah. All right. All right, here we go. Solve the logarithm equation. ln x plus 3 plus ln x plus 5. Again, we're solving for x. It's natural log, so I'm going to write natural log. You want one of them. Big parenthesis, open, x plus 3, close, open, x plus 5, close, equals 0. Now, ln and e's are inverses of each other, guys. So later on, when we get more advanced, I'm just going to tell you to e it, e to the power of that, e to the power of that. But for now, we're not there yet. So I'm going to tell you, turn this into a log with a base e. Log base e of x plus 3, x plus 5 equals 0. Next, you're going to turn this into an exponent. E to the 0 equals that expression. So e to the 0 equals x plus 3, x plus 5. Anything raised to the 0 is 1. 1 equals x squared plus 5 plus 3 is 8x. 5 times 3 is 15. I want to solve for x, so I'll need to zero this out. Minus 1. 0 equals x squared plus 8x plus 14. Nope, not factorable. Two numbers that multiply to give you 14 that add up to 8. Well, 1 times 14 is 14, but 14 plus 1 is 15, so that doesn't work. And 7 times 2 is 14, but 7 plus 2 does not add up to 8, so that doesn't work. And that's it. Those are the only factors. So with this one, we are forced to use the quadratic formula. Negative 8 plus minus square root 8 squared minus 4 times 1 times 14. All this is over by 2 times 1. And I just take my calculator and I'm going to type it. So here's my calculator. Let me clear this. I'm going to use the alpha feature. And let me see. Negative 8 plus square root 8 squared minus 4 times 1 times, was it 14 or 15? I already forgot. 14? All over 2 times 1. You don't have to put the 1. I know that you can be faster with it, but I'm just showing all the little numbers. So at least 3 digits. I'll store it to a letter. I'm going to store it to A. So negative 2.5857. 3 digits truncated at least after the decimal, the thousands place. X equals negative 2 point, and I already forgot it. What was it? 58567. And I'm going to store that to A. And then now I'm going to do the same thing, but instead of plus, minus. So I'm just going to scroll up and put minus. So scroll up and change the plus to a minus. Don't worry, guys. I know. We're almost done. We're almost done. Minus. Bam. Negative 5.4142. Negative 5.4142. Negative 5.4142. I'm going to store that to B. So let me store that to B. Did I store that one this way? Yeah. Store alpha B. We're almost done, guys. We're almost done. All right. Looking at the domain, let's see which one can I not be. X plus 3. So x has to be greater than negative 3. X has to be greater than negative 5. So using the most restrictive one, actually, just, okay, well, doesn't matter. It can't be that one. But even if we were to try it, you'll see right now, you would still figure it out. So I already stored it in A and B. So x plus 3, x plus 5. I think I can remember that. So check it out. Natural log is next to the number 4. Natural log, alpha A, I think I said plus 3 plus 5, right? So natural log A plus 3 plus natural log A plus 5, and I better get 0. Bam. It works. If I scroll up and I type in the B, I better get an error because it's not part of the domain, which you would figure it out anyways when you're checking it. So let's see, alpha B. Sorry, guys. It's been a weird day today. Alpha B and alpha B. And voila. So, see? Doesn't work. All right. Let's see what we got. Is that it? Okay. Go to your activity. We're going to do 2 more together, and then we'll call it a day. Okay, here we go. Which one was I looking at? I just don't like, see, when I push the maximize button, guys, it should take the whole screen up, but I can see a part of it that's not taken up. I don't like that. Why is that bug? Yeah, well, I'm probably going to have to restart it, right? So that's a programming issue. So someone programmed, and that's a bug that they got to fix. Okay. All right. Look at number 7, because we haven't done a quotient one. Those are one of the examples I deleted by accident. So we're going to do number 7 together. We're solving for x, but there's a minus in the middle. So instead of the product rule for logs, we're going to do the quotient rule for logs. So I'll put a side note. I'll put it here on the side. Log A minus log B is the same thing as log parenthesis A over B. As long as B is not, well, okay, we'll just, as long as B is not 0. Log base 2, giant parenthesis, 2x minus 1 over x plus 2, close, equals negative 1. Utilizing that rule right there. All right, now we're going to turn it into an exponent. 2 to the power negative 1 equals that expression. So 2 to the power negative 1 equals 2x minus 1 over x plus 2. Once you get it to look like this, guys, remember your law of exponents. So this dude right here, that just means 1 over 2, or 1 over 2 to the power 1. So let's rewrite it like this. 1/2 equals 2x minus 1 over x plus 2. And I think you guys have been doing cross multiply since you guys were in 5th grade, right? At least. Right? So you're just going to cross multiply, guys. So 2 times 2x is 4x. 2 times 1 is 2, so 4x minus 2 equals, and then 1 times anything is itself, so x plus 2. And now we're going to solve for x. Move the x to the one side, so 3x. Move that minus 2 to the other side, so equals 4, and then divide by 3. X equals 4/3. And then don't forget to check it. Check it. And it does, it works. We'll check it. Let's check it. Let's not skip out on it. So hook me up with the expression. Log base 2. I always use the original. Log base 2. And then it was, instead of x, we're going to say 4/3, right? 4/3. Oh, it was 2? Yeah, 2 in the front. Second, insert 2. And then 2 4/3 minus 1. And then get out of there, minus math log base 2. And then what did I have on this one? 4/3 plus what? 2. All right, push enter. And there it is. It equals negative 1. It works. Cool. Okay, one last one because this question gave you guys, well, gave not you guys, but the other groups trouble. Look at number 8. The reason why it gave kids trouble, or some of the kids trouble, is because math books have it like this, but that 4 is for the x minus 9, so really they should have another parenthesis right here like that. So remember that when you're typing that into the calculator, so we'll do it together. So here we go. I'm going to do it in blue so it won't get confused with that red over there. So we're going to use the log rule for this. So I'll move that 4 right there. So I'm going to have 4 ln giant parenthesis. Now that I've gotten rid of that 4, now you can just write x minus 9 equals 8 without the need for another parenthesis. If you want to put another parenthesis, you can. And what you want to do, since you want to solve for x, guys, you want to get rid of that 4 first. Because this is 4 times ln of that. So how do I get rid of the 4? Yeah, divide by 4, divide by 4. So now you're going to have ln of x minus 9 equals 2. And then turn this into a log with a base e. So log base e of x minus 9 equals 2. And now we're going to go into turn into an exponential. E squared equals that expression. E squared equals x minus 9. Move the 9. X equals x equals e squared plus 9. And there it is. Let's check our answers. Hey, why isn't it coming? Let's check our answers. Yeah, now I got that song stuck in your head. I'm sorry, miss. It is a good song, TBH. Yeah, that one's a good one. Here we go. I'm gonna type in. What was I gonna type in? Yeah, e squared plus 9 or something. Let me store this into a letter. E squared. The e's where the ln is at. E squared. Was it plus 9 or minus 9? Plus 9, and I'm gonna store this to a. So every time I push a, it's gonna be that number. So here we go. What's the original? ln, open parenthesis, x, or a, minus 9, close to the power 4, and then close. And I better get what? 8. 8. How do we feel, guys? All right, we're done. That's it. It's not due, the assignment, until, I think I put the due date Saturday, but I think if you guys are fast enough, you can turn it in today. Or, turn it in tomorrow, I guess, also.